A new theory about the clay on Mars' surface could rewrite the history of the red planet. Previously, researchers have suggested that Mars needed to have had water on its surface to form clay. But the new study suggests that Mars' early atmosphere was a high-pressure steam bath that transformed the planet's solid crust into soft clay. Millennia of volcanic eruptions and asteroid impacts then spread this clay out into the patchy surface we see today. Backed by lab experiments and computer models, the team lay out how the scenario would have worked. In the very early solar system, Mars and other rocky planets are thought to have been covered by oceans of molten magma. As the Mars magma ocean began to cool and solidify, water and other dissolved substances rose to the surface as gases. This formed a thick, steamy atmosphere around the planet.The moisture and heat from that high-pressure steam bath converted vast swaths of the newly solidified surface to clay. As the planet then evolved over billions of years, volcanic activity and asteroid impacts covered the clays in some places and excavated them in others. There are thousands of ancient clay outcrops on the Martian surface, which are formed when water and volcanic rock interact. This means for clay to have formed on Mars, the planet must have had surface water at some point in its history, according to some scientists. But climate models created by researchers at Brown University in Rhode Island suggest an early Mars, where temperature rarely crept above freezing and where water flow on the surface was sporadic and isolated. If this is true, vast deposits of clay were, and might still be, present beneath the Martian surface. Those deposits could explain why the Martian crust is less dense than expected for a basaltic crust, the researchers said. The deposits would also serve as large underground storage reservoirs for water, which could have implications for past habitability, they said. Backed by lab experiments and computer models, the team lay out how the scenario would have worked. As the Mars magma ocean began to cool and solidify, water and other dissolved substances rose to the surface as gases. This formed a thick, steamy atmosphere around the planet.The moisture and heat from that high-pressure steam bath converted vast swaths of the newly solidified surface to clay. As the planet then evolved over billions of years, volcanic activity and asteroid impacts covered the clays in some places and excavated them in others. It was this that led to the widespread but patchy distribution seen on the surface today. The basic recipe for making clay is you take rock and you add heat and water, said study co-author Dr. Kevin Cannon. This primordial atmosphere created by a magma ocean would have been the hottest and wettest Mars ever was. It's a situation where you could pervasively alter the crust and then just shuffle those materials around afterward. Dr. Cannon and his co-authors say the scenario offers a means of creating widespread clay deposits that doesn't require a warm and wet climate on early Mars. Instead, water flow on the Martian surface was rare and patchy thanks to the planet's freezing temperatures, the researchers said. We think this is a plausible way to explain much of the widespread clay we see in the oldest Martian terrains, study co-author Professor Jack Mustard said. To demonstrate that the model is plausible, the researchers created rock samples matching the composition of Martian basalt. After cooking samples for 2 weeks, the team found they had been altered remarkably, as their model predicted. The steam atmosphere associated with the magma ocean could have survived for as long as 10 million years or more, Dr. Cannon and his colleagues say. That would have been long enough, they estimate, to create as much as 2 miles, 3 kilometers, of clay on the primordial Martian surface. To get an idea what the fate of that clay might be as the planet evolved, the researchers created a computer model to simulate a slab of Martian crust with a 2-mile, 3 kilometers, clay layer on top. Then they simulated the first billion years of Martian geologic history, the period when volcanic activity and asteroid bombardment were most prevalent. The model showed that the burial, excavation and scattering of clays over time created distribution of exposed deposits similar to what's seen on Mars today. To put some numbers on it, clays cover about 3% of the oldest crust exposures on Mars, Dr. Cannon said. We're finding about that same order of magnitude in these models. The lab experiments and simulations can't say for certain that this scenario occurred, the researchers said, but they do suggest a strong hypothesis that could be tested during future Mars exploration.